Hi guys, I'm gonna do section 1.5 uh, quadratic functions, which the shape is called parabolas. Um, Here I hope to cover these uh, topics: introduction to parabola, uh, plot parabola using points, um, transformations. I believe you guys learned this before, but I'm gonna uh, go through transformations. Then I'm going to discuss about the equation and graph in parabola. Uh, we're going to see two ways to, uh, means two types of equations of the parabola. Then we see um, a few examples or applications from optimization. Okay, first types and parts of parabola. Um, we have to know what parabola. The we call parabola this shape. Let me erase this stuff from previous slide. Okay, now okay. As you see this parabola here, this line, um, and uh, you see we call parabola this shape. The parabola could be upwards. If it open upwards, we call it downwards. If it open downwards like this, or open left or open right. Now this one is a slanted parabola. You see the its axis, it is not horizontal or vertical. Now we not going to discuss this type of parabolas. We not going to do this type of parabolas here in this class. We deal only with open upward parabolas or upward parabolas in short, or downward parabolas. Now let's see its parts. Now in this diagram, um, we see x and y axis. As you know, where this graph intersect the x-axis, they are called x-intercepts. And where it, so you see it intersect x-axis at two different points here, but it is not necessary. Imagine if you have access system like this and with this parabola, right? With this parabola. So it does not intersect the x-axis at all, but it intersects y-axis at this point, right? So that means a parabola may intersect x-axis at two different points, may touch the x-axis. For instance, it is like this. You see, it is simply touching here, there. That means we can consider it intersect only at one point, or it intersect no points like this parabola, right? So if it intersect x-axis anyway, those intersection points we call x-intercepts. Um, where it intersects the y-axis is called the y-intercept of the parabola. What's specific with parabola is its vertex and its axis of symmetry. Vertex is the tip of the parabola. Um, if it is if the parabola open upwards, like um, in this case, um, it has a minimum value. If the parabola is like this, open downwards, it has a maximum value. This is a minimum value. Okay. The vertical line passing through this vertex divide the parabola into two equal parts. It is called the axis of symmetry. This line. From this line, it divides the parabola into two equal parts and is called the axis of symmetry of the parabola. Okay. Okay. Now, let's see how to plot a parabola. Y equals x square, a basic type of parabola. Now to draw this parabola y equals x square, we can use the simplest method that you learned with the equation of line. Um, Means we take few values for x and corresponding y value we can find substituting that x value in the given equation y equals x square. But keep in mind, parabola is not a straight line. Uh, oh, for a straight line, just 2 points is good enough. But since this parabola is a type of curve, 2 points is not enough at all. Um, it's coming down and going up, so around the vertex, we have to get a couple of points at least. So here we get 2 points to the left of the vertex and 2 points to the right of the vertex, and these points left to the vertex. You may wonder how we know it. You will see that later. And we're gonna learn better method, in fact two methods later on, just to get the shape. I do this using these points. So I get points -2, -1, 0, 1, 2, and substituting y equals x square. I found these y values. Means if you substitute -2 here, uh, first time you get -2 square, which is +4. Do the same thing with other values, -1, 0, 1, 2. We get all these y values. Um, then plug these x and y coordinates here on the graph. We get this parabola. Right? This is y equals x square. Y equals x square is same as in function notations fx equals x square. These two are identical. Okay. Right. Now go to the next slide. Transformations. Now, I believe you guys learned transformations, but as I said, I'm gonna um, give you quick uh, introduction about transformations and how to do it. About this, I uploaded a document to the Blackboard. Let me see if I can share that document if I could find. Okay, here it is. Okay, I uploaded this to the Blackboard. Um, Vertical shift is open. First of all, the graph we're considering is f of x. So if it has vertical shift, if it is fx plus c, if it is vertical shift downwards, fx minus c, horizontal shift, reflection about x-axis, reflection about y-axis, all these things are here. You have to be familiar with this. Just looking at this table, you do not get an idea. After you see the see few graphs, how it's behaving, um, then only you can understand this table. Therefore, I'm gonna share a few graphs I did using the online calculator, Desmos online calculator. Um, Here it is. Okay, let me clear all these. Now I use um, fx equals x cube. I did x cube. X cube graph goes like this, right? Don't worry how we get this graph, x cube. Pay attention to transformations. Now, fx equal to x cube plus 2. That means you add 2 to each point. So it is obvious this graph should move upwards 2 units. See, this blue line is fx plus 2, x cube plus 2. If it is x cube minus 2, what do you expect? Uh, this red line, we hope this red line will go down 2 units to negative 2. Let's see if it's true. Yes, so it goes down. Now, I'm going to take away those two graphs. Uh, Now, x cube, pay attention this graph. Now, if you replace this x with x plus 2, if you replace x with x plus 2, you get x plus 2 whole thing square, this fourth graph, this one. Notice if it is x plus 2, it shifts to the negative direction, right? Therefore, we may expect if it is x minus 2, it shifts to the positive direction or to the right. See, it shifted to the right. Now, you may play with this Desmos online calculator. It gives you a good idea. Also, if you do at least a few graphs by hand, substituting a few x values and calculate the corresponding y value, it will give you a good idea about these transformations. I'm going to take this off. Now, if you multiply this x cube by a negative, it will flip, means positive side goes below the x-axis, negative side goes above the x-axis, and it is a, a reflection about the x-axis. If you multiply the whole function by the negative sign, it gives you a reflection about x-axis. Now, if you replace x with negative x, I'm going to take this off. If you take off x with negative x, it gives you the reflection about y-axis. In this case, it gives you the same previous uh, graph. Means if you look at this graph carefully, the reflection about x-axis is same as reflection about y-axis. This is reflection about x-axis. Reflection about y-axis is this one. See, it's the same thing. See, reflection about x-axis of x cube is same as reflection about y-axis. Right? Okay. Now, if you multiply the function by a constant whole number, 2x cube, it gives us this. Um, this is called vertical stretch. Now, if you multiply the function by a fraction, say 1/2, it's a uh, vertical shrink, this blue line. Now, if you replace x with 2x, if you replace x with 2x, it means whole number times x. It's a horizontal uh, horizontal shrink, and if you multiply that with a fraction or fraction times x, if you substitute x with fraction times x, in this case I use half x, it is a horizontal stretch. It's stretched horizontally, right? So these are the basic transformations you got to know, right? So be familiar, you have to know these basic transformations with um, other type of graphs, not just with x cube, x square, x cube, whatever the graph is given. Um, Play with few graphs using Desmos. You can get fast results, right? Then you will be comfortable with these transformations. Right, let me go back to our lecture note. Okay, that's about transformations. Now, equation and graph in parabola. Um, as I said at the very beginning, we use two types of equation. There are two types of formulas people use to write the equation of parabola. Quadratic functions are parabolas. Uh, Now, the type 1 is fx equals a times x minus h square plus k. There, the vertex is given by h comma k, right? If the question gives you the equation in this form, ax minus h square plus k, do not try to um, square this, then distribute and simplify it to ax square plus bx plus c. Leave it as it is. Get h comma k. H is here, k is here. When you compare, uh, make sure the sign here should be negative. With h, it should be negative, and k, this should be positive. In case you um, get a negative number here, you should change. For instance, if you, when in the equation, if you have negative 2 at the end, then you write this as uh, plus minus 2, right? Then in that case, k is negative 2. Um, that is simple algebra. I believe you know it already. So watch out for these signs. the sign here should be negative and sign here should be positive. All right. Uh, the uh, rest is the same. Um, we know to find the y-intercept, we set x to 0. To find x-intercept, we set fx to 0. Fx here means y. Right? Uh, and then uh, find some test points by substituting some x values from both sides of the vertex to the given equation and find corresponding y values. Plot the graph and label x and y-axis, vertex, axis of symmetry, and x and y intercepts. Right, let's see the type 2. In type 2, fx equal to ax square plus bx plus c. Right? If the question gives you the equation of the parabola in this form and asks you to graph it, um, do not try to convert into the other form. It is um, hard. Um, simply calculate the x coordinate of the vertex. The vertex coordinates of vertex is given by this formula. Don't upset with this y coordinate. It looks complicated. All you have to do is calculate this x coordinate of the vertex, which is negative b over 2a. This is what? This is the x coordinate of the vertex vx. Right? Then to find this one. What is this one? This is the y coordinate of the vertex. Um, what you got to do is substitute this vx value um, in the given equation. Substitute it here and here. Then you get the corresponding fx value. That is the y coordinate of the vertex. This is vy. Right? The rest is same as the other equation to find the x-intercept, y-intercept, test points, then plot in the graph. It's same as the other equation. Those things are common. Let's see an example. Um, sketch the graph of the parabola y equals negative 2 x minus 3 square plus 8. Now, if you compare this with y equals a x minus h square plus k, um, you see first of all a is negative 2. If a is negative number, okay, I think I didn't mention that with the previous slide. Now see here, fx equals a x minus h square plus k. If a is a negative value, it opens downwards. If it is a positive value, if a is a positive value, it opens upwards. Same thing with this one. A is negative, open downwards. A positive, open upwards. Right? Now, when we apply to an example, we will understand that better. Now, in this case, A is negative, A is negative 2. Therefore, it opened downwards. It go like this. At the vertex, if you compare this negative h equal to negative 3, therefore h equal to 3. See, signs are the same. Therefore, you shouldn't worry about finding signs. Um, if this plus 8 was negative 8, then k is negative 8. But in this case, this is positive, therefore k is positive 8. So h comma k, we can say the coordinates of the vertex is given by h comma k. Therefore, v should be equal to h is 3, k is 8, 3 comma 8. The vertex, this is 3 comma 8. Then we want to find y-intercept, x-intercept, and some test points to plot the graph. We say for y-intercept, x equal to 0. Substitute that in the given equation. We get y equal to negative 2, 0 minus 3 square plus 8. This is negative 3 square is positive 9. 9 times 2 is 18. Negative 18 plus 8 is negative. This is negative 10. Therefore, y-intercept is what? Therefore, y-intercept equal to, we get this substituting x equal to 0, is 0 comma negative 10. This is y-intercept. Now, for x-intercept, what we do, we set fx to 0. Now here, fx means this y. This is same as fx. Therefore, if you set y to 0, we get negative 2 times x minus 3 square plus 8 equal to 0. Let me solve it here. Move this 8 to the other side, we get negative 2 times x minus 3 square equal to negative 8. Divide both sides by negative 2, we get x minus 3 square equal to, divide by negative 2, we get positive 4. Then get the square root on both sides. When you get square root, don't forget to add plus minus. We get we get x minus 3 equal to plus minus square root of 4 is 2. X equal to um, with plus we get 3 plus 2 with minus we get x equal to 3 minus 2. This is 5. 3 minus 2 is 1. Therefore, um, x-intercept, we get this substituting y value to 0. Therefore, it is 1, comma 0 and 5, comma 0. X-intercept. That means this graph has two x-intercepts. So uh, graph opens downwards. Now we found almost everything we need. 1050. This is 3, comma 8, and y-intercept is 0, negative 10. So it's something like this. It intersects here at negative 10. These 2 points, we found 1 and 5. Let's do this graph on the um, other slide. Just keep in mind this is x and y. Just keep in mind the shape of the graph. It's going above this x-axis. 3, comma 8 is the vertex. This point where it intersects is negative 10. X and y. Now knowing the vertex, coordinates of the vertex is 3, 8. Can we write the equation of this line, axis of symmetry? This is the axis of symmetry. The equation of the axis of symmetry is what? Now look, axis of symmetry, it has nothing to do with parabola. Um, it's a vertical line. We know it passes through this vertex, which is 3, comma 8. So if it is a vertical line, its x-coordinate never change. Therefore, x-coordinate equal to the x-coordinate of the vertex. So the axis, the equation of the axis of symmetry is x equal to 3. Right? This equation is x equal to 3. So that's all about this parabola, right? Now let's see another example of the other type of equation, right? We'll clear this. Okay, sketch the graph of the parabola y equals negative 2x square minus 8x plus 12. We want to sketch this parabola. Looking at this, the coefficient of x square, is negative. That means, again, this parabola open downwards. This means it open downwards. Now, the x-coordinate of the vertex is given by Vx equals negative b over 2a. Let's calculate this. Negative b is negative 8 divided by 2 times a is negative 2. This is what? Negative 2. Right? Now, this is the x-coordinate. To find the y-coordinate, we substitute that x-coordinate in the given equation. Substitute this here in the given equation. We get negative 2 times negative 2 square minus 8 times negative 2 plus 12. 4 times 2, negative 8 positive 16 plus 12. Negative 8 positive 16 is positive 8 and 12 is equal to 20. Therefore, vertex is given by x coordinate is negative 2, comma 20. Okay, now x and y intersects. Let's go to the other slide. Okay, let me erase this stuff. The given equation is y equals negative 2x square minus 8x plus 12. It's same as fx. I for y-intercept set x to 0, then we get y equal to negative 2 times 0 minus 0 square minus 8 times 0 plus 12, which is 12. Therefore, uh, we get y-intercept as 0, 12. Then let's do x-intercept here. For x-intercept, set y to 0, then we get negative 2x squared minus 8x plus 12 equal to 0, divided by negative 2, we get x squared plus 4x minus 6 equal to 0. Okay. Now, to solve this, uh, we learned few methods to solve this. Either we can factor this or use quadratic equation or completing square method. But factoring is the easiest if it is factorable. But in this case, can we find factors of negative 6 that gives us positive 4? No. 6 times 1 is 6, 3 times 2. None of them gives us positive 4. Therefore, factoring is hard. It means it is not factorable. Now, is that a part of the question? Do we have to find x-intercept? Unless question asking you to find x-intercept, um, finding x-intercept is not a must. Let me go back to the question. Sketch the graph of parabola y equals negative 2x squared minus 8x plus 12. Right? Now, it is not that we cannot find answer for x. We can find it is existing if you calculate the discriminant of this quadratic equation. It is positive, therefore we should have two distinct answers for x. But in this case, since there are no factors, let's see another way to uh, do this, not to solve this. Um, we already have this one, y-intercept. This is 12. Um, do we have to find these 2 points? Not really. Instead, okay, just with 2 points we cannot do this. We at the moment we have this, which was negative 220. We have 1 point, 2 point. We cannot do a parabola with 2 points. We have to have at least one more point. But let's find 2 points. How? Just substituting uh, a number for x. I said we can uh, substitute number on both sides of the vertex. This is the vertex. Now let's decide what x values to substitute. Let's substitute uh, one number on the left side and one number on the right side. Negative 2 is here. Therefore, let's substitute negative 3 and negative 1. Because this number is negative 2. Right? Both sides of the vertex. So this is a good example for me to show you how to do that. The given equation is y equals negative 2x square minus 8x plus 12 when x equal to negative 1, we get y equal to negative 2 times negative 1 square minus 8 times negative 1 plus 12, 8, 20. This is 18. Then substitute x equals negative 3. We get y equal to negative 2, negative 3 square minus 8 times negative 3 plus 12. By symmetry, it cannot be different, but do this calculation, you should get 18. Um, Therefore, we have coordinates of two other points on the parabola, negative 1, comma 18 and negative 3, comma 18. This point, negative 3, comma 18, this point, negative 1, comma 18. Right? This point. Okay. Once we have 1, 2, 3, 4 points, we can do the parabola. Now, the axis of symmetry, the equation of this line is same as x equal to x coordinate of the vertex, x equal to negative 2. Equation of axis of symmetry, x equal to negative 2. Alright. So we did the parabola, we found vertex, uh, axis of symmetry, unless the question asking you to find um, x-intercepts, you don't have to. Instead, you means you cannot just avoid that and do the parabola. If it is not factorable, simply find two other points. Give two x values and find corresponding y values. The parabola should go through those points, right? Okay, let's move on to another example. Okay. applications. Applications to optimization. We use um, uh, to optimize functions. This concept of um, maximum minimum thing with parabola. Typical problem that arises in calculus is to determine the maximum or minimum value assumed by a given function. If the function is quadratic, then it is clear that its optimal means maximum or minimum value will occur at the vertex. Right? Now in calculus, we're going to learn a different method to find maximum and minimum point. But if it is a quadratic function, just from the vertex, we can find the maximum or minimum value. Okay, let's see this example. A ball is thrown vertically upward from the edge of a building. Wait a minute. Let me get the. Okay. A ball is thrown vertically upward from the edge of a building 160 feet above the ground. D is missing here. With an initial velocity of 48 feet per second. It can be shown that its height h measured in feet above the ground is given by the equation where h equals this. Okay. The ball is thrown vertically upward from the edge of a building. Okay. Say this is the building, this is the ground. Um, what's the height? Height of the building is 160 feet. The ball is thrown vertically upward. Ball is here, throwing up. Initial velocity v equals 48 feet per second. It can be shown that its height measured in feet above the ground is given by the equation. Okay, height above the ground is given by this equation h equals negative 16t square plus 48t plus 160. That is the time measured in seconds. Determined in part A how long it takes the ball to reach its maximum and what is this height. Okay, for maximum, now looking at this, this is a parabola. How do we know? It's a quadratic equation, t square. Um, Therefore, we can find the time to reach the ball to its maximum height. How we find that t equal to, when t equals to negative b over 2a. This is a, b, c. Negative b is 48 divided by 2 times a is 16, negative 16. 16 times 1, 16 times 3, negative divided by negative is positive. Therefore, this is 3 over 2. Okay. This is the answer to part A. How long it takes the ball to reach its maximum height, and what is this height? To find that height, we can substitute this 3 over 2 for t. This is seconds. Corresponding height we can find negative 16 3 over 2 square plus 48 times 3 over 2 plus 160. 2 times 1, 2 times 24. This is, when you square, this is 4. 4 times 1, 4 times 4 is 16. This is 9. 3 square is 9. 9 times 4 is negative 36. Plus 3 times 24 is 72 plus 160. 1 this is positive 36. Uh, if you add 36 to this, 96. 196 feet. Okay. Um, Means this h is the maximum height. Time to reach this maximum height is 3.3 over 2 seconds, or this is equal to 1.5 seconds. Okay, that is part A. In part B, how long does it take for the ball to hit the ground? Um, how do we find that? Um, when the ball hitting the ground, um, h equal to 0. H gives us the height of the ball above the ground. Let's go to the other slide with this equation, negative 16. H is given by this. Okay. Oh, I have it here. I copy it from here. The part B, h equals to negative 16 t square plus 48 t plus 160. How long will it take the ball to hit the ground? So to substitute h equals 0, we can say negative 16 t square plus 48 t plus 160 equal to 0. We can divide the whole thing by negative 16. Then we get t square minus 3t minus 10 equal to 0. Factors of negative 10 then gives us 3. 5 times 2. We can see uh, t minus 5, t plus 2 equal to 0. And this gives us t equals to positive 5 or t equal to negative 2. We reject the negative answer. Reject because t time should be greater than 0. Right? Therefore, t equal to 5 seconds. This is the answer. Answer to part B. That means it takes total of 5 seconds uh, from the beginning to uh, hit the ground. Right? Okay, let's move to the next slide. I'm gonna clear this. Okay, a farmer will construct a rectangular enclosure from 1200 feet of fencing. He plans to subdivide the enclosure into 3 parts as illustrated below. Determine the dimensions of the enclosure that maximize the enclosed area. Okay, now construct a rectangular enclosure from 1200 feet of fencing. Okay, the how long is the fencing? It is 1200 feet uh, in 3 parts. This figure is given. Okay, uh, we can see area. Now, using this figure, area is length time width. You can see A equals to xy. Now, length of the fencing means this whole thing from this here all the way here, these lines, these vertical, all these vertical lines plus these 2 horizontal lines. The length of them should equal to um, how much? How many feet? 1200, 1200 feet. Yeah. So let's write the total length here. 2 horizontal sides. Um, what we write is the total length of fencing. Twelve hundred feet. So it is Uh, we have four vertical lines with length x, therefore it is 4x plus two horizontal lines with length y, it is 2y equal to 1200. Now let's solve this equation for y. These two are the equations we have. 1 and 2. Um, Now if you divide both sides by 2, we get 2x plus y equal to 600, and solving for y we get y equal to negative 2x plus 600. Now substitute that this y value here in equation 1. We get a equal to x times um, negative 2x plus 60. Determine the enclosure that maximizes the enclosed area. Okay. So this is equal to what? Negative 2x square plus 60x. Now see, this area function is given by a quadratic equation. A is area function. Um, so you see its coefficient of x square is negative. When coefficient of x square is negative, it is which way it is opening? It open downwards. Go like this. That means it has a maximum value. Therefore, we can say for maximum A, maximum area, x equal to, we use the equation negative b over 2a negative 60 divided by 2 times a is negative 2. This is positive 15. Wait a second. Here I made a mistake. This is 600. I write 60 here. I dropped 1 0. I had to have that here. This is 0, 600x. Negative b is negative 600 divided by 2 times negative 2. That means I have to have another 0 here. 150. Okay, this is the x value, and we can find y value substituting this x value here in this equation. Corresponding y value, y equal to negative 2 times 150 plus 600. This is negative. Again, I'm writing 60. This is 600. This is negative 300 plus 600 is 300. Right now we know both x and y. So these are the dimensions um, of the enclosure. We found x is 150 feet, y is 300 feet. These are the dimensions. We can find the um, maximum area multiplying these two. Therefore, maximum area is equal to 150 x times y, 150 times 300. 45,000, 45,000 square feet. Square, or we can write 45,000 square feet. All right. So this is all for section 1.5. Right. Thank you for watching this.